Hello, my name is Mike Britton, and I am a 3DEXPERIENCE CAD and CAM specialist here at GoEngineer. I'm really thrilled to talk to you today about one of our advanced 3DEXPERIENCE design roles, the CATIA Lattice Designer role. Before we get too far into this video, please make sure to subscribe to the GoEngineer YouTube channel so you can keep catching great videos from us and demonstrations from my fellow colleagues. Today's tool, CATIA Lattice Designer Trigram LTX, is a new 3DEXPERIENCE role. This role is used to modify our 3D CAD designed parts for additive manufacturing. Since additive manufacturing is now a mature and robust production technique, we need to be able to take advantage of the unique geometries this method gives us. Like our other CATIA branded roles, this is an advanced design role with unique capabilities not found in other software suites, and it is fully integrated into the 3DEXPERIENCE platform. Designing, simulating, and validating our designs before committing to production is a critical element of modern design processes. There's a lot of software which claims to be able to do this for additive and latticed parts, but that's usually happening in the slicer or in a standalone software package that does not integrate associatively with the rest of the modeling, simulation, and PDM or PLM toolchain. CATIA Lattice Designer uses implicit modeling to apply lattices to our conventional boundary representation or BREP solids. For those of you unfamiliar, BREP gives a formula for the shape of each edge of a surface as well as the topology of that surface. It makes sketching easy to do since we're defining the formula for some cross-section of the surface right away, and the feature defines the topology of that surface. If you've taken our surface modeling class, you'll know that solids are composed of knit-together surfaces to create fully enclosed volumes. Implicit modeling, instead of using a formula for every single edge and surface in a solid, uses a single formula to define the entire volume in space. Pure implicit modeling generally utilizes what are called primitives. Usually a cube, sphere, cylinder, or cone are used with Boolean operations to create a part. If you are truly old school, you may recognize the similarities with computational solid modeling. Most solid models in the SOLIDWORKS world can be defined by similar geometry to those primitives, but traditional implicit modeling does leave a lot to be desired when we get to drawings and assemblies. We're now in a position where we have extremely well-established modeling practices in a BREP environment like CATIA or SOLIDWORKS, but our manufacturing technologies can leverage large gains in part lightweighting and material savings. If we could create implicit primitives of these lattice structures and jump between BREP and implicit modeling environments, we could create great things. And wouldn't you know it, CATIA Lattice Designer does just that. Implicit modeling is extraordinarily useful for highly repetitive geometry where we start to encounter problems with traditional BREP design tools. Consider those lattices we can see in the images on the slide. If we had modeled each edge and surface of those extremely finely detailed beams or lattice structures in our usual CAD tools, we'd spend all year waiting for parts to rebuild or resolve. The promise and value of CATIA Lattice Designer is that we can design our parts in our traditional solid modeling environment, add our lattices for light weighting or to formalize how the part will emerge from our 3D printer, and utilize our simulation and validation techniques before we ever begin printing. If a part needs to be revised, our lattice will associatively update with the part's design without ever having to re-enter the Lattice Designer environment. In addition to these incredible benefits for CATIA Lattice Designer, starting in 3DEXPERIENCE R2024X FD01, drawings of latticed parts are now supported in the SOLIDWORKS Manufacturing Definition Creator role. This means that when using the X-Drawings application that is the featured app of this role, that you can create detailed drawings of your latticed parts. Additionally, there is increased support for using conformal cooling within 3D Mold Creator, another SOLIDWORKS browser-based role on the platform. Now that we've gone over the basics of Lattice Designer, let's take a look at a very basic workflow inside of this software. First, you'll notice that I've started off with a part designed in SOLIDWORKS XDesign, or SOLIDWORKS 3D Creators role. And to take a look at this role, some software platforms might call these modules, things like that. As I click on the compass here for the platform, we can see that my top level here are the roles that have been assigned to me. I have a few more roles than your average bear because I'm here to demonstrate them to you, but these are generally allocated or presented as job functions. So 3D Creator is this role here. We can see that it has SOLIDWORKS branding, and I click on that and we can see all of the applications that come with this role. XDesign is the featured application for this role, and as we can see right here, we are in my XDesign application. I have designed this part in XDesign, and what I want to do is get a couple of lattice features inside of here. So I want to lattice out these flat areas out here on the sides, and I'm going to add a gyroid to this interior cavity here. One of my favorite tricks in the platform is that I can take this window and I can just click and drag my top level into what is called the Rich client for Lattice Designer. I am able to launch this application, we can see here in the background, by just coming down to my role or plain old searching for the app and launching it there. I already have this up because I want to show you this sweet trick, which is just clicking and dragging. And now the part is getting pulled down from the platform to the local client. The Lattice Designer application is in what's called the 3DEXPERIENCE Rich client. Just like there's desktop SolidWorks, we have a lot of desktop 3DEXPERIENCE roles available to us. For many of you, I'm sure that this is your first look at the Rich client, so let's take a moment to establish a few things about it. One, I did a little prep work to click into the Lattice Designer role already to show the applications that are included here. We don't just have lattice design, but we have a lot of other things involved. And one of these key roles in here is called natural shape. I won't be demoing natural shape today, but we can use this to directly edit our imported files to prepare them for latticing and additive manufacturing to make sure that we have sufficient clearances on post-processing. If I click back out of here, we can see all of my 3DEXPERIENCE roles there as well. I'm going to close out of my compass interface for now, and I want to take a look at navigating the interface first. We still have our compass just like we do in the web browser. We can see that we are in 3DEXPERIENCE, and then after this bar, it tells me that I am in CATIA Product Structure Design. We can see in my action bar that I have a handful of tabs around here, but none of these are set up to edit this part and prepare it for actual latticing. That is because we are currently working under this top level, the physical product level. If I double click the 3D shape here, take a look at the application name change. We are now in CATIA 3D printing preparation. That's because that was the last role that I was in, or the last app rather. So if I just come into Lattice Designer and click Lattice Design, it will now transition me over to Lattice Design. In SolidWorks, we have our command manager at the top. Here in the Rich client and in our web clients, we also have our action bar, but this is down at the bottom. Here I have my lattice design exploration, and I have a handful of commands that I can use to get this part ready. To fully prepare this part for latticing, what I need to do is make sure that my edits are going to go in the correct place. CATIA and CATIA-derived products have a concept called ordered geometric sets and also disordered geometric sets, but geometric sets are basically where your features happen. I'm going to make sure that my new features happen in the correct geometric set by right-clicking this Design Features and say Define in Work Object. Now, that'll ensure that any edits that I make to prepare this for latticing will happen in the correct space. As I expand this geometric set, we can see all of my features like I would in my normal design feature tree. In order to lattice, I need to define these areas and say that these volumes here here, here, here are all areas that can be latticed. This interior pocket will be easily picked up by the existing features, but I need to put a partition in these other areas to make sure the software knows where to look. So let's define some of these volumes. I'm going to use this volume extrude command right here on my Lattice Design Exploration tab of my action bar. And it is asking me for a profile. I'll select this profile. For the direction, it's asking for either an edge that goes in that direction or a plane to be perpendicular to. So in my tree, I'll right-click my XY plane to show, and I'll select that XY plane, and we can see that profile has been extruded up. I'm going to reverse the direction, and instead of using a length, I'll say up to element and choose the bottom face of this part. I'm using this up to element because if my design should change and these little flat areas change in dimension, this will associatively update. So I'll say OK. And we have our volume extrude. Now, how do we tell Lattice Designer that that is an area that needs to be turned into a lattice? Well, I'll make a partition out of it. So I'll select my partition command here, also on my action bar. The volume to partition will be this whole volume here, and the cutting element will be the one that I've just made there, and I'll select OK. There are a couple of different workflows. This is the one that I'm going to use for the rest of today's demonstration. And now all I'm going to do is come around to my other positions and do exactly the same thing. You can see I have my volume extrude 9 here and my partition feature there. So let's lather, rinse, and repeat 3 more times for these other areas. Volume extrude, choose my face, choose my direction, reverse, and select my limiter. There we go. Create my partition, select the volume, select my cutting element, say OK, and we'll continue onward. Okay, now we have our 4 separate partitions, and we can get this part into the Lattice Design Assistant workflow. My Lattice Design Assistant button is right here, and it's asking me to create a design set. So I'll go ahead and hit my plus button. It's asking for the design to lattice. In this case, I'll be choosing my design features ordered geometric set. I'll say OK. For my cavity volumes, this brings up an additional little assistant. And when I say plus cavity, we can see that we have first by intersecting volume. We just created a bunch of partitions, so I'm going to grab my partition volumes. And I want these to be separate cavities, so I'm going to do this a couple of times here. But first, here is my one partition, my second partition, my third partition, and my fourth partition. The last partition is the rest of the volume that I do not want latticed. For another cavity, I'm going to hit my plus button, and I'm going to select shell. And for my shell faces, I'm going to grab one of these interior faces of my pocket. I have automatic propagation on, and that is closed appropriately, so I'll say OK. We can see that this has filled in as well as a nice little planar top to it, so that is going to be my fifth area. I'll say OK. And we have our cavity volume specified, so now let's do our conceptual design. We can see all of my volumes are here. I'll hit the cavity name there to highlight it to make sure I know what I'm looking at. And there's no defined lattice, so I'll hit my plus button. And we can choose our structure. This is another dialog here. We have a regular BCC cubic. I'm going to choose this dodecahedron, and I'm just going to say preview to see how this looks. say OK. Now, that has a nice series of lattices. I'll say OK for that one. It's a little finer than I would want in real life, I think, for a demo piece, but it goes to show the kind of advantages that this implicit modeling workflow has. For my next cavity, I'll come to the other side. Let's put a honeycomb over here. I'll hit my plus button. I'll come down to my honeycomb, and we'll make this guy a little bit bigger in every dimension. I'll hit preview. That's pretty nice there. I'll say OK. Now we have our two side cavities to do. Our wireframe previews stay in place, which is really nice. This guy on our right-hand side, we'll hit our plus sign. And for this one, we'll just choose another one. We can grab our diamond, for instance. Hit preview. There we go. That looks good as well. And then our second to last external area, maybe we can get something. The BCC cubic is nice. And I'll make this guy substantially larger. Hit my preview button. And there we go there. So now we have a variety of lattices in all different kinds of shapes out here. And I'm going to fill this central pocket with a gyroid. So I'll hit plus, and now I'll come over to my TPMS side, and we can see that we have a bunch of different TPMSs. That's triply periodic minimal surface. I like gyroids the most myself because I think they're neat. For this thickness, I'll say 1. One thing that I want to say is that there is a button here that says Define Opening Faces. This is part of a highly automated workflow for heat exchanger design. If you design heat exchangers and you're curious about what metal additive manufacturing can do for you, keep your eyes glued to the GoEngineer YouTube channel. We're definitely getting something out on that. I'll just hit preview for now, and it's going to think. These TPMS previews are a little bit different from the rest of the wireframes, so they take a little bit longer for the preview to come through, but nothing too crazy. And there it is. We have our TPMS preview inside. We'll say OK. And once again, you can see that we have wireframes for everything else. We have an actual repeating surface for our gyroid there. And I like the way that all of this looks, so I'll hit OK. So we have our concept design done, and now it needs to compute some information for us now. This dialog is going to give us some information about how everything works. So we have this lattice here that only has a 4.38% fill volume. This lattice over here is 23.91%. That one is not getting anything, and the TPMS has not been computed. So I'll hit my compute there. And we can see that we got our information there as well. It's a 21.58% fill rate. And it shows how much volume in cubic meters is being occupied by all of this. But look at that, we've saved 36.21% on material here. It's not too shabby. I'll hit OK, and now all that needs to happen is I'll hit the lattice detail design. There is some sagging that occurs here, and this is how the meshing is presented in the graphics. For me, because this is additive, I just crank up my smoothing value for the most part. This decimation sag has kind of an interrelation between your design intent and the minimum feature size of whatever machine you're putting this on. 0.5 millimeter works great for me. 0.5 millimeter, 20 thou. And I'll just say OK. And we are going to let this volume compute. Our latticed body has built, and we got one warning out here. This is just telling me about some precision that's set up with, and that's related to our decimation sag and feature size. It's usually this guy over here that creates that kind of a problem just because it's so fine and dense. I'm gonna hit close on that though. It just adjusted the value to be the maximally appropriate one. And let's take a look at the quality of the latticing that we have here. First, as we come in, we can see that there are no sharp transitions to kind of what I'd call the parent geometry. We have a smoothed out transition from our lattice to that main body, and that is going to make sure that our lattice doesn't just kind of crumble to bits as it gets manufactured. So let's take a look inside of here as well, and we can see that these are all looking really nice. The lattices are not extending completely to the boundary down here. We can tweak some settings and do some DFM techniques on this to get those to extend all the way through if that is a desired output. But what I want to show you is that unlike a lot of other systems, we don't have to really do any post-processing on our lattice work. There are no kind of dangling thin features extending all the way to the line as you sometimes get in other places. All of our lattices end at a strong joint, and that's regardless of what methodology is being used to create them. So you don't have to worry about small bits breaking off or kind of having to trim off any floating geometry or anything like that. We can just have our lattices terminate at these strong end points and joints. Now inside of here, we have our triply periodic minimal surface that has come through really, really nicely. I'm a big fan of how that looks. And again, we can see some of this smoothing in the corners between that lattice and its parent geometry. So that looks really good to me. And what I'm going to do is save this here on my rich client, and then I'm going to take a look at the part because that is going to update back in XDesign where I originally designed it. So we have the save here, and I'll jump back over to that app. Here we are back in XDesign. You can see that our part is coming through really nicely. We are still getting our arcs and true kind of NURB surfaces out here where they are relevant inside of XDesign, but we can see that the lattice is coming through really nicely. In our rich client, to send this out for 3D printing, we could hit this equivalently placed arrow. In the web clients, this does some other stuff, but what I can do here is just use this to export, and I could export this as an STL or a 3MF file to prepare this for 3D printing. Back here in XDesign or in any of my other CATIA apps, I'd be able to put this in for assembly creation. For in our Simulia apps, we can do simulation. We can do all kinds of things because this is treated just like any other native piece of geometry, despite being created in a totally novel workflow for the 3DEXPERIENCE platform. Thanks so much for joining me on that live demo. The Lattice Designer software is absolutely one of my favorite new pieces of software that the 3DEXPERIENCE platform gives us access to. And while you've seen that, there's a lot of interesting information that we've gone over, but there is something that we need to talk about. Who is Lattice Designer For? Well, the easiest answer goes to service bureaus and design consultants. You can take anybody's parts, pull them in, and apply a latticing workflow to them. If you have other 3DEXPERIENCE roles and applications that you're using for your business, then you can integrate with those in a much deeper fashion as well. So if you used, for instance, CATIA visual scripting, then you can do things like create your own various 3D nodes and things like that inside of visual scripting, connect it with Lattice Designer, and have your own implicit modeling customized setup done there. One of the apps that we didn't touch on is the 3D printing preparation app as well. That will let you modify meshes and heal and fix faces and things like that to make sure a part is watertight and prepared for 3D printing as well. So this has a really big benefit for design bureaus that are already using some 3DEXPERIENCE or really just any SOLIDWORKS channel applications. Now, for companies that are already utilizing the 3DEXPERIENCE platform, these are extremely useful capabilities as well. There is a single caveat that I want to make. Even if you are using SOLIDWORKS Connected, even if you are using the Design with SOLIDWORKS connector for 3DEXPERIENCE, parts made in desktop SOLIDWORKS will not maintain associativity with the platform. desktop SOLIDWORKS parts can be imported into Lattice Designer, but they won't maintain associativity if you make a design update. That's not always a deal breaker for folks, but it is something that does need to be mentioned. However, desktop SOLIDWORKS is not the only SOLIDWORKS. We also have our 3D Creator role, which I love. It's essentially SOLIDWORKS in the web browser. 3D Sculptor is for nice subdivision surface modeling, great for product design as well. And then some other browser apps like 3D Sheet Metal, 3D Structure Creator, 3D Mold Creator. 3D Mold Creator especially has great functionality with CATIA Lattice Designer because 3D Mold Creator parts can have conformal cooling made with those gyroids for heat exchangers inside of them. It's really amazing. And need I say more, all CATIA design roles also are supported by CATIA Lattice Design. So mechanical designer, creative designer, mold and tooling, visual scripting, 3D pattern shape creator, that's a browser one. I have another video on 3D pattern shape creator. It is another wonderful application. And function-driven generative designer also will create parts that can be utilized in CATIA Lattice Designer. If you have an industry where weight matters, and I believe that is every industry these days, that you will get benefits from Lattice Designer, even if you don't have your own 3D printers, even if you contract them out, or if you have a design partner that works with 3D printing and additive manufacturing. CATIA Lattice Designer is an incredible game changer, and I hope that you'll really be able to take the benefits from that back to your workplace. Thank you truly for your time in watching this video. I relish the opportunity to show all of these fantastic new tools off to anyone who's interested. If you have any questions, my email is right there in the description. You can reach out to us over at GoEngineer, leave a comment. We have our community on the GoEngineer website where you can ask questions in the forum. And once again, thank you so much. Please hit that subscribe button to keep an eye out for our future videos and deep dives into Lattice Designer. That's right, this is just the beginning, and I hope you have a wonderful day. Thank you again, and take care.